All right, welcome everyone. So, again, this would be really the summary of the topic plane area, right? In the previous classes, we've done reduction, enlargement. Now we're really going to be finally going on to a real world example called a machine part, right? We're going to reduce and enlarge in a machine part, right? And I took the time out to scan the page. So let me just quickly go in that page that I scanned. All right, let's go here. Give me a moment. And while that page is loading up, I'll just check if there's anyone in the waiting room. All right, there seems to be none. But let's continue. Let's continue. Okay, so let me just check for that file. Okay, Google Drive. All right, because I had originally planned for you just to look in your books, but since no one is here, I'll have to just go for the soft copy backup that I have. All right, excellent. Here we go. So it's radial line, method B. It's loading up, or is it that this is crashed? All right, there we go. Excellent. Fast forward a little bit if it's taking too long to load. All right, there we go. So, yeah, I scanned the page just to ensure that persons who don't have the book can still look at something while we're speaking. So before we go into the drawing, let me just quickly recap on what we've done. So, in the past class, I said we've learned how to reduce and enlarge in plane figures. All right, we learned direct method A, which is where you really had a four-sided figure, quadrilateral, and you had to reduce it, right, and enlarge it in one plane. Then now we went into the radial method A, right? This is where you had a point perspective outside of the drawing. Then now you connected that point to every vertex and edge, right? And you essentially now use those as your parameters to get an enlarged photo or a reduced photo. And all throughout that, we've used something called ratios, which was discussed in module 2, right? In module 2, we talked about the fact that if you have a ratio of 3 to 5, you use line division and divide it into 5, and then know the point at which third occurs, that's the point of occurrence. So in the case of ratios of 3 to 5, wherever third division on that line is, that's where the origin of that drawing will be. Okay, so let's go to method B. Here we go. So in method B now, it says to enlargen a photo or diagram, such as the engine part here, using radial line method B. We learned method A already. It says on a base of XY, right? Draw the given shaded figure. But in the case that someone is here, I'm gonna just disable the waiting room. Okay? It says draw a given shaded figure using your own measurements. And I have given you your measurements. Let's go there. So if you're on the virtual website, technical drawing S3, today's date, November 20. All right, November 20, here we go. I have said that the region AB, right, must be 50 millimeters. Let's look at AB right here. Let's zoom in. So AB would be this long distance vertical here. Let's draw that. All right. So let's go here. Yeah, let's quickly. All right, there we go. Slash drawing. Good. Let's use our construction line and use a thin point. I'm gonna draw now our AB. Wait, let's put it over here. There we go. All right, that's good. Let's enlarge it. All right, excellent. Okay, good. So let's label this our A. I should really draw it smaller. About here. That sounds good. Yeah, about here. Gonna call this now our point of A and our point of B. All right. Now, this region is only one of few because the next measurement that I told you is that the distance C, which is a horizontal line now, should be 10, correct? 10. So now we're going to draw a horizontal line of 10. Label that RC. All right. Now the next distance is a vertical line, right? Connecting back up, and we're going to make that be 10 as well. All right. Vertical line upwards to 10. Right? And here's where the region D now begins. Let's put D. So D now, it's stated to be a distance of, scroll up, 10. So now we can draw a horizontal distance for D. Here we go, that's 10. Then now we have a slanted line, a 45-degree interval of E. No, F rather, F, right? So that region F now will be 15 millimeters. So let's dictate that we have an angular displacement somewhere here. That's gonna be now F, 15. Okay. Now, so in other words, this should be a bisection of 90, 45. All right. Let's look at the next one now. Next part is told to be a radial line or arc of G. That radial line of arc G is 15 millimeters in radius. But we don't know exactly where that region begins, as you can tell. So what we would need to do is to work around by finding A to H first. So we're going to extend firstly A to H. I'm going to say that total distance from B to this extreme end here will be 10, right? Plus 10 plus 15, right? This arc would be 15 as well. So let's add them. Let's put a calculator. Let's say calculate 10 plus 10 plus 15 plus 15 plus 10. 60. Okay, so we're going to draw now a horizontal line of 60. There you go. All right, when we draw the horizontal line now, we can begin to mark off where our center would be by firstly, let's check, okay, there's no one still in here. By firstly looking for the distance from line H to circle 2. So from here to circle 2, that would be a region of 25 millimeters. So we're going to step back 25 millimeters. We're going to say measure 25 millimeters, and we found it to be here. Let's put it in red to show it's a center line. Found it to be here. Excellent. Then now we're going to just draw the circle, because now we know that that distance is 25. Okay, good. But we don't know still the boundary as to which the horizontal line is. You know where it resides, but we don't know where exactly inside it is. Well, let's look closely. We know that it's gonna arrive at the point H horizontally. So what we could say is that given from this point downward, go down a certain distance. So all we need to find out is this distance, which would be 10. So the distance down to the center would be 10. Let's go down here. Distance down to the center would be 10, about there. All right, let's still just join here. And there we go. Excellent. But you wouldn't draw this, essentially. Remember, it's just to highlight here. Because we know now that that's the point. This detail that that's the center point. And then we'll begin to just draw the arc. All right? So let's look at the arc. So the arc begins at where the slanted line ends. I would say it, and we can just highlight now the entire drawing. All right, excellent. Okay, so now we need to fill in the circles. So based on where that circle was, let's just highlight it. When I say the center point is here, the radius of that circle is given to be, let's see. So the radius of this circle is given to be 8, right? Because we can use our own measurements. So we're going to just decide to be 8. So 4 millimeters in radius. If it's too small, you can use a larger radius because, again, you're using your own measurements. So here's what I'm going to do. I'm going to draw it with that center of radius 8. All right. So that's how really to get the initial drawing. But again, because I'm sketching it, yours should look a little bit better than mine. All right. Okay. Now let's get into the meat of the matter. So that was step 1, really. So let's go into now the first official step in getting this drawing. So we're going to say step 1, locate P at a convenient point outside. I'm going to call my P to be here. And as you can remember, that objective now is to connect all points to P. All right, let's connect. There we go. Connect all points to P. That was a bad line. Bad. Try it again. There we go. And let's just draw it there. All right. Again, yours should look fairly better than mine. But I am thinking after this module, I'm going to begin to use AutoCAD. Right? Because that's the level where we're going to be at now, where I can just draw the diagram virtually and you'll be able to see it. Okay. So after we finish with the sketch, the next step is that we're going to now find an enlargement of that diagram firstly. So the first thing we're going to do says we locate the point P and we're going to extend now a division of P to B in equal to 5 equal parts. So let's go back to P to B. Let's label that our point here is P. Label that our point here was P. Here we go. P. And this distance now, which should be in details, should be determined. So we're going to say, for example, that distance is 60 millimeters. You're going to now create a line division. A line division at a specified 45 angle. Let's have it open more. There we go. All right, depending on the length of the entire diagram, connect it. There we go. All right. Then now divide this line into 5 equal parts. So we're going to say part 1 is here. Part 1 is here. 2. 3, 4. Right? And place the line at every point parallel. There we go. Okay, excellent. So we have divided our line P to B to 5 equal parts. Okay. Now let's see the next step. The next step is from B, continue the equal divisions, right, to point 11. And we went through this step already where we talked about the fact that, hey, in your mind, whenever you see 11 out of 5, that is really saying you continue the divisions from 5 and go to 11, right? So whenever this region stops, so we're going to say this region stops here, we're going to continue to say region 6 is here, region 7 somewhere here, 8, 9, 10, 11, right? So that would be 11 out of 5. But again, I'm going to use AutoCAD the next class to really show exactly the end result of this. But I want you to practice though using this, albeit terrible looking sketch, because I'm honest, it's not the best looking. Okay, good. So now when you understand that you're going to extend the divisions from 5 to be 6, 7, 8, 9, 10, 11, the point at which it begins at 11 will be now your enlarged photo. The point at which it begins at, let's see the ratio. The ratio for the small version is 2 to 5. That will be now your small or reduced photo. So let's do the enlarged photo first. So the first thing we're going to do, we're going to extend the line A. So here's the line A. We're going to extend it further. Here we go. We're going to extend the line H. So let me finish labeling firstly. But I have a sense that the simplified drawing though really helps you to really appreciate your drawing when you have done it. All right? So I will ensure that in the next class you have accurate representation of what is to be done. All right? No longer sketches will be done. But let me just detail this quickly. So this would be H, and this would be our region G. Okay, good. So let's extend those lines. All right, so H would be here, G, F, right, D, all right, let's check 1 second. All right, good. So because B is horizontal, we would not need to extend anything. We'll just really highlight that B continues and it actually begins here. So we can highlight that this will be our enlarged photo for the new B1. Let's put B1, B, oh my bad, B1. Okay. Okay. All right. So let's continue now to draw this diagram. Okay, good. But there's something that we're missing. You realize that this is radial method B. We're not doing radial method A where we just draw it as such. Thing that we're going to use now to really find the points, right, is radial arcs. So it says project AB to K and A prime, B prime to K prime. Let's look at where K is. All right, so project AB to K and A prime and B prime to K prime. Let's do that. Okay, so we're going to extend this line, and wherever the intersection of AB, let's extend a construction line. here, this would be called K. K. There we go. K. All right. Let's do the same thing here. We're going to extend this line again. This region now will be called K prime. K prime. All right, excellent. Okay, now once we've gotten the K and the K prime, we now have a region to depict the other information in the drawing itself, not just those vertical lines A and B. Because we have no A prime, B prime, which came from AB, but we need to know where G prime, D prime, C prime, F prime, and H prime, along with I prime, will come from. Right? So let's go at it. So now we're going to say, from P, draw radial lines through all points on the figure, including centers of circles and horizontal center lines on circles. Okay, now what does this mean? From the region P, from the center point P,